Okay, today we're going to be looking at our notes here say applications of quadratic functions, but really what that really boils down to is we're going to be looking at how quadratic functions factor into real life situations or real life equations or real life scenarios. And so it talks about here, it says the graph below represents y, the height of the ball in height in feet of a ball, and x, the seconds after the ball was thrown upward from the bridge that crosses the river. So a couple things we want to keep in mind. Number one, even if we were to graph an equation, we have to remember that when we do something that involves the real world, we are only focused on the positive points or the positive intervals. So when it comes to x, it's 0 and everything to the right, and then when it comes to y, it's 0 and everything up. So we're only focused on quadrant 1, and if you'll notice on the graph, you don't see anything to the left of 0 or below 0, and that's because those don't exist when it comes to talking about a situation in real life. So when we look at that, you're going to notice some differences. You're not going to see the rest of our parabola. You may only see part of it. If you were to graph the whole thing, you're going to see all of it. But again, we're only going to keep track of what happens after 0. All right, so again, it asks us number one, it says, what is the y-intercept of the graph? So again, nothing changes there. Our y-intercept is right here. And so the answer is 0, 80. Okay, and what that represents is the y-intercept is the initial height of the ball. So before the ball was thrown, the ball was 80 feet off the ground, which exemplifies the fact that it was on a bridge. All right, now it says after how many seconds did the ball reach its maximum height? So again, the maximum height is going to be what we call the vertex. So we want to find that single highest point where that curve starts to peak, and then as it rolls back down. So in that case, it would be right here. It asks us after how many seconds. So the answer to that would be 2 seconds. So after 2 seconds, that ball reaches its maximum height. Okay, and then again, it asks us what the maximum height is. So we would look for the height at that point, and the answer would be 144 feet. So that ball is 144 feet off the ground. Okay, then it asks, how long did it take the ball to reach the surface of the river? So in other words, we're looking for what we call the 0, right? The point of impact, or the point where the ball landed. In this case, the ball landed here, which was 5 seconds later. Okay, so the ball reached the surface of the river 5 seconds after it was thrown. So it's 80 feet up on the bridge when it's thrown up to a maximum height of 144 feet, and then after 5 seconds of being thrown, the ball lands in the river. All right, again, looking at a second one, it says the profit of a t-shirt company is represented on the graph below. Y represents the profit, and X represents the selling price. Again, they want to know what the maximum profit is going to be. So we would look at that, and we would have to figure out the point where our vertex would be. So again, we're looking, and that vertex is going to be approximately right here. Okay, so we're going to be looking at around 60. It looks probably about, what, $6,200 be the maximum profit that they can make off this t-shirt. It says, what is the selling price needed to reach the maximum profit? So if we look, again, these are going by tens, so we're in between 30 and 40, so that would be a $35 t-shirt. And then it says, at what selling prices will the company not make any profit? So again, we're looking for the zeros, right? No profit, 0 here and 0 here. So if the shirt costs $10 or $60, they're not going to make any money off of that t-shirt. So again, when we're looking at real world situations, we're looking for places that looking for all those same key features, whether it's a vertex, a minimum, a maximum, looking for roots, looking for y-intercepts, but looking at how those interact or how those play out in a real life situation.